All right, here we go. All right, so, yes. All right, let's read this first together. No, we don't have to read it together. Yeah, popcorn. The logarithm, popcorn meant no. Base b of a positive number is defined as log base b of x of y if and only if b to the y equals x. Can be read log base b of x is log base b of x, b of x. Anything new in that sentence? So we can say y is the exponent, right? So when you see this equation, the equals is our exponent. Is that new? If I don't have a number for b, what's my base? 10. We call that the common log. A logarithm that uses base e, we call the natural log. So you can write log base 10 as log base e as natural log. And a logarithmic scale uses the quantity of the log to let you know the magnitude of change. This paragraph is a review of everything we've done so far, right? So now what we're going to do is we're going to take that information, and I'm not going to add anything new, but we're going to look at behavior of graphs some more. Because I don't know if you've realized the big thing of pre-calc is analyzing graphs. All right? That's why. All right, so, you probably don't notice because of this. All right, so let's talk about character. It's a bipolar neuron. Yeah, that's right, internet. I can do more than just math, kind of. I'm a mediocre math teacher and a mediocre science teacher. Put them together, I'm almost a full. Oh, yeah. I actually go to Delta. I love Delta. All right. So let's say my parent function is y equals log base b of x, right? Again, this is going to be a review of our transformations because it's important to know this stuff because you're not going to be allowed to use a calculator for a lot of the tests, right? So the better we are at transformations, the better we are at graphing and understanding without a calculator, okay? Who's Mr. Fuller will? All right, if I change this to y equals a times log base b of x, that is a vertical dilation of a. Now, just a reminder, if a is greater than 1, it's going to stretch it. If a is between 0 and 1, it will shrink it, right? How do I reflect over the x-axis? Remember the axis, my one in the middle. Yeah. If I put that negative in front, right? Or you can think about it as a less than 0, right? So if I have an a and there's a negative, it will flip it over the x. Because the way I always think about this, if you want help, or the way I remember, if the negative's in front, that means all my y's are negative. Like if I move that negative over, and when I change my y to negative, I move it down. Does that make sense? So I flip it down. So if I want to reflect over my y-axis, my negative goes in front of my x, right? Oh, thank goodness. Log base b of negative x. Or I'm going to write another way too for funsies. Log base b of c times x, where c is less than 0. Because remember, if you've done a lot of graph transformations, they usually use a as a vertical thing and c as a horizontal thing. What is an omission? What are we missing in this left side that we have in a lot of graphs? What don't we have? We don't mention asymptotes, that's true, but we're doing a vertical stretch, and we're going to be doing shifts, translations. We aren't doing horizontal stretches or horizontal dilations. Because will it change a horizontal compression dilation? Will it do much to our graph? am I going to ever have to worry about it when I draw the graph? Not really. So that's why we don't pay a lot of attention to on these. Translation, if I do y equals log base b of x minus, what letters do I usually do? H plus k, right? Vertex form. What did I do? Ooh, you guys want to get real tricky? You guys want to see something real neato? Or no? What point do I always have in logs? 1, 0, right? What's that going to go to? 1 plus h, 0 plus k, right? Does that make sense? Because it's opposite in the parentheses plus. I don't memorize it that way. You guys are really good at shifts, so I'm not too worried about it. If it's on the outside, it's up, down. If it's on the inside, it's left, right. Does that make sense? Inside the parentheses. It's left, right. You guys know how to, you guys have done really well with that, so I'm not too worried. You know what? Go watch some of my previous videos and like and subscribe. And you can also donate. There's a little donate thing, right? Not for me yet, but for bigger people, you can put donate button. I don't know. Yeah. I'm not worth anything, they said. Google called. Here's a question for you, Internet. How come we all know like Bill Gates and Microsoft and Steve Jobs and Apple, but no one's like Googling who? You know what I mean? Like who? There has to be someone who has, like Bezos and Amazon, Musk and Tesla. Like who is it? Who is the Google? Is it the dinosaur from the loading screens? Who knows? If I'm not here tomorrow, it's because they found out. And they're like, oh no, he knows too much. All right. Oh no, I might not be. Waka waka. All right. So if I combine them all, I get y equals a. Yeah, a times log base b of. Do I need my c? I'm not going to put a c because I don't care. No. Someone just drops down. It's like, you know too much. All right. Let's get to it. So we haven't even done one example yet, and I want to get through 3 examples today.
Yeah, you got first. Yeah.
Well, 9 was gone because 7 ate it. All right. So, what's going on in my graph here? What's my rule going to be? Up 3, right? I'm actually, watch, you guys want to see some, I'm going to do something a little bit different. You don't have to do it this way. But I'm going to take is my x going to change? What's happening to all my y's? So if I know my original graph, I take them all and just move them up 3. You don't have to write that. I'm just, I try to show you different ways a lot, okay? So, again, you know, what's our translate then? What are we doing? Like, in words, what are we doing? We're moving up 3. So that's the difference between a rule and a translation, right? Do they mean the same thing? Yeah, but I'm just trying to introduce you guys some terminology. Is that all we really need? So I'm going to add this too. What's the one point we know is on every log, basic log graph? So what's 1, 0 going to go to? Okay. So remember, we got to use those key points. Like with quadratics, we use the vertex, right? And with rationals, we use the asymptotes. Do you remember that? Exponentials, we use 0, 1. All right, what's happening with this one? Let's see if we can make a rule. Let's see how good we are now. I keep adding stuff to this. What's going to happen? What's that negative do to all my y's? What's the negative going to... That's going to flip over x. So what's that? What's the 2 going to do? Vertical stretch of 2. And what's that 3 going to do? Could I say dilation, vertical dilation of 2? So let's make a rule for all our points. What happens to every single one of my x's? What's it mean to go right? Right 3, right? What's that negative do to my y coordinates? It flips them all negative. And then what's the 2 do to all my y coordinates? So that's my rule. So again, I'm just showing you guys another way to do this, right? Could I do this for everything we've learned so far? Yeah, and then you take each point and you plug it in. I'm not going to right? This is by translate, right? Vertical stretch of 2, flip over the x, right 3. So what's going to happen to 1, 0 on this one? It's going to go to 4. And what's negative 2 times 0? Okay. How are we doing so far? Well, that's good.
What do you rate us?
I don't know. I've just been doing. Me do. You know do yet.
Why is it y 0?
Because negative 2 times 0 is 0. Yeah. All right, let's take a look at this log. This is weird. If you can't see this well, can I rewrite this as negative x plus 2? Is that a more common format that we're used to? Remember, with addition, subtraction, we can always rotate them, right? Do I do anything with that 3 as my base? No, because that's just part of the function. Like, we didn't do that with our exponentials either. It just lets us know growth or decay. It does nothing for us. So what's this? What's that negative in front of the x do? Flip over y. So what becomes negative? The x does. When I flip over y, my x is becoming negative because my x became negative. What's this plus 2 going to do? Left 2. So if I want to make a rule, what happens to my x? My x was pretty negative. That's why I dumped her. She's probably watching. No, I'm just kidding. She couldn't do math. That's why she's... No, I'm just kidding. All right, so that's a negative x, right? Because you guys told me that. What's the left 2 do to it? Minus 2. What happens to my y? Nothing. So what happens to my 1, 0? Negative 3, 0. Because it'd be negative 1 minus 2 is negative 3. Test tomorrow. Let's go. I'm going to do it. Maybe. Did you guys see example 9? Oy, oy, oy. Oy. Oy vey.
Always good.
Yeah, what?
All right.
No,
Let's graph it and analyze. Sound good? So I'm going to put the parent function up here. Oh, that's crisp. That's good. Look at that curve. That's pretty good for a mediocre at best person. So that's what natural log looks like, right? So what am I going to do with that graph? Oh wait, I also have an asymptote at what? X equals 0, right? What's the plus 2 do to it? Moves that left to... Oh, I can just draw it in here, can't I? Let's do that. So I'm going to move my asymptote to negative 2. And that's... Where's 1, 0 going to go to? Negative 1, 0. Is that enough to graph it? To draw a sketch? Because what do I care about? I care about intercepts, asymptotes. Ooh. Yeah, that's all I'm going to care about for these. No, I'll show you what we're going to do for that. It's going to be amazing. All right. That's not bad. What's my domain on this? What's up, Emma?
Does it, instead of 1, 0, doesn't it usually start at 0, 1, and then the inverse of 0?
You're thinking of exponentials. Exponentials start at 1, 0, or 0, 1. These start at 1, 0. Because remember, zeros are asymptote. We can't touch 0. It's like an electric fence. So what's my domain on this? Negative 2 to infinity. We've done a lot of these, so I'm going to go relatively quick. What's my range? Yep. Do I still have an asymptote? What equals negative 2? X is vertical. Do I have, how many intercepts do I have? Do you guys agree 1 is at negative 1, 0? And that's my X intercept. And the other one, my y-intercept, watch this, is going to be at 0 natural log of 2.
Yeah. Why?
I'll tell you, no, because that's going to be, when I plug in 0, it's natural log of 2, right? Is natural log of 2 a rational number? So is that an exact answer? Yeah. Is that an allowable answer? Yeah. If this, because what kind, would this be a calculator or non-calculator question? Non. If you have a non-calculator, how do you have to answer this? Natural log of 2. I got it by plugging 0 in for x, right? When I plug in 0 for x, I get my y-intercept. All right, what about concavity? Down. I'm going to add something to this. This is different. My rock is decreasing. This is just a review of chapter 1. A rock. What's happening to my average rate of change? Yeah, because just a reminder, this is my slope at this point, right? And my slope here is less. So to be concave down means my average rate of change is decreasing. Again, I just want to make sure I keep cycling stuff with you so when we get to the test, it's not scary to be like... Do you know what's going to blow your guys' minds when we go back to review and you do unit 1 and we're doing basic transformations and you'll be like, how did I struggle with this when I was in it? That's my goal. We'll see though. All right, what's my left end behavior? What's my limit of f of x as x goes to infinity? As I, oh wait, that's not left end. You asinine fool, Mr. Twiggler. I would approach negative 2 from the positive side, right? Because that's where it ends. Negative infinity, because am I going down or am I going up? Down. Like my stocks. Just kidding. Yeah. All right, what happens to my right end is my limit of f of x as x goes to infinity is it going up or down? Up. Are we gonna have time? All right. Here. Actually, you know what I want to do? Work with people around you. You guys try B. Just give it a try, and then we'll compare it. I'm going to do it too, but we'll compare. I actually think that'd be better. All right. All right. So do you guys have any questions on how I got my domain? Range? Did my asymptote move? Where did I get the 0.10 from? So remember, my y-intercept is when x equals 0. My x-intercept is when y equals 0. So I take this equation and I set it equals 0, right? Subtract a 1. So I get -1 equals log of x, right? What's my base? So 10 to the -1 equals x. And what's 10 to the -1? Yeah, because I moved the it's 1 over 10. So remember, for y-intercept, I know there's 1. Or no, I'm sorry, there's no y-intercept. For my x-intercept, I know there's 1. So I got to set equals 0 and solve. Sound good? And behavior's okay? Really, what's the only thing that changed? I mean, only a few points changed, right? Let's do one more. I don't need to do it. I'm going to go through it. Yeah, we should. It's a reflection. I shouldn't have even erased this. I'll start over again. All right. So, do I know what natural log looks like? Natural log looks like all the other logs. With 1, 0, right? Again, so this is a strategy I use. I always graph the parent function before I do transformations. It just helps me like process like what I'm doing to it. Could I rewrite this as natural log of -x plus 3 to help me out? Okay. So that means, ooh, I could do that. Should I do it that way? Go left 3, then flip it. What do you guys want to do? Go left 3, then flip it, or flip it? If you do that, you have to pull the negative out in front. Yeah, let's do left 3 and then flip it.
Yeah, I agree.
Yeah.
Nope, you still gotta do. Nope, never mind. Still gotta do it this way. That negative has to be going through all my x. So here's the trick. I need to pull out a negative and make it negative x minus 3. No, I could have flipped it first. Hold on, guys. Let's try it. Worst case scenario, I'm wrong, right?
Yeah.
I'm pretty sure I can move it and then flip it. So left. No, it won't. It won't work. Yeah, it will. It will. 100%. 100%. I stand by this. 100%. My asymptote's usually at 0, right? If I go left 3, where does it go? It goes -3. And then I flip it, and where does it go? So my asymptote is at 3. Do you guys agree? You guys see what I did there? I went left 3 to -3, and then I flipped it over. I have to go left 3 and then flip it. We good? I'm just making sure it works. Order matters. Now, oh no, well, yeah, it will work. So I take my point 1, 0. I'm going to go left 1, 2, 3, right? To -2, 0. And then what do I do? Flip it to 2, 0. 100% that works. The other way would have worked too. If you do the flip and then translate it, because you would have flipped it and then moved it. You get the same answer either way. But if you do it that way, you have to go right 3, not left 3. So you pull negative out front. So if I keep it this way, I translate and then flip. Some books teach it the other way. That's where I was going off. This is the way I do it. So that's my graph. Now, I'm not done yet. Easy. If I flip it, instead of going this way, which way is it going to go? Down, right? No, because I went left 3 and then I flipped it. We go left 3, then flip it. Left 3, and then flip it. So when we went left 3, is it?
Oh, so that's okay.
So 1 went to -2, and then we flipped it over. Like a pancake. Pancakes. All right, so my domain is -infinity to 3, right? My range is still -infinity to infinity. Where's my asymptote? X equals 3. Where's my intercept? 2, 0, and 0. When I plug in 0, what do I get? Can you do that in your calculator? Yeah, can you do it in your head, though? Nope. These should be the same thing. 3 minus 0 is the same as -0 plus 3. Am I concave up or down? Still down. Yep, still. No, we're not going to make it. Left end behavior. Now that one's my limit as x goes to -infinity. Because now I can go to the left, right? There's nothing stopping me. I can go all the way over here. They don't get that joke on the internet because people on the internet don't understand jokes. All right. So what's my limit of f of x as x goes to 3 from the negative side? -infinity. Oh, no.
What? 6 we got time. 6 minutes. Oh my.
Oh, yeah. Since your team, now you have to come to our.
Nope. I can do this. Oh my gosh. Oh my god. Actually, you know what? Y'all can do this, maybe. I'll do whatever I don't get done, I'll make in a video. And hopefully I'll be here tomorrow. End behavior. What's happening as my x keeps getting bigger? What's happening to my y? So what's going to happen as I go to infinity? As I go to infinity, the function's going to go to. Do y'all see that? We've seen problems like this, right? Just not with logs. Logs. I'm from Boston. Hit the ball wicked hard. All right. Now, as I go to the left, what's this keep getting closer and closer to? 1. Oh, yeah, because this isn't a log, it's a exponential, right? And with exponentials, I have, why did they do that? With exponentials, I have a horizontal asymptote, right? So if I were to graph this to give myself an idea of what's going on, there's an asymptote at 1, and it goes off to infinity, right?
How do you know it's one?
Because this number keeps getting closer and closer to 1. So what's the value of k got to be? What's my normal horizontal asymptote? What did I do to it? Went up 1, so k has to be 1 because we shifted up. Right? We're going to do it. Let's go. Shifted asymptote up 1. I think it said.
Yeah.
Yeah.
Beautiful.
Yeah, we will. Oh no, we're not going to finish.
I don't know.
We're not. All right. All right, what's my base? Here's how you do it. Do you guys remember this from a long time ago? No. Watch this. It's 0.5, 1, 2, 4, 8. What am I timesing by each time? 2, because it's it's exponential. So what's my base got to be? 2. So my base is 2. Do you remember when we kind of did that to break it down? It's exponential. So find the different, you're multiplying by 2. If it's 3, 9, 27, it's 3. 5, 25, 125, it's 5. So 10 would be 10, 100, 1,000. Yeah, I can't finish this. Yay, I'll finish it for later, like lunch. I should just pause this and come back and finish it on the whiteboard.